Welcome back. We're going to continue our discussion on synthetic routes of ketones. Now, aldehydes and ketones, they do share a lot of similarities in terms of the reagents used. So the one reason that I did not say as we synthesized aldehydes, particularly the initial synthetic route, is when you have a primary alcohol and you use strong oxidizing agents, it tends to go into acid instead of just stopping at an aldehyde. Okay, so primary alcohols, we did mild oxidation, which we can carry those out with secondary alcohol as well. Okay, should have been secondary. Okay, and you do not have to remember these reagents because these are exactly the same reagents we used. So again, all of these contain chromium. Typically, chromium and oxygen is a pretty good indication you're carrying out oxidation because they're oxidizing agents. Now, secondary alcohol, you can use both mild oxidizing agents and moderate to strong oxidizing agents. It makes no difference. It just goes to a ketone and just stops there. And that's why with primary alcohols, we use only mild oxidation procedures, whereas with secondary alcohol, we can do both both mild and strong oxidizing agents. Again, you see that sulfuric acid makes it very aggressive, and this is called Jones reagent. And this also oxidizes a secondary alcohol to a ketone, whereas some of these reagents, which are milder oxidizing agents, they also oxidize the secondary alcohol to a ketone. But what is really the product? Well, just like how we replace the OH with a double bond O for a primary alcohol, this is a secondary alcohol. So all we're going to just do is replace the OH with the double bond O. Whether you're doing a mild oxidation or a strong oxidation, well, it's the same exact reactant. We're going to use this reagent over here. I don't want to rewrite it. Again, it's an aggressive oxidation, but nevertheless, the product is the same. All we do is replace the OH with a double bond O. And if you're a brave soul, go ahead and name these compounds. Well, they're both the same, so just name it once. Okay, so it's already in the line structure, so you should have no problems naming it. So go ahead and name it. And I think there's a bit of an exception in this case, but you can still name it. All right, so go ahead and try it, and this will be part of your my thoughts. And let's look at maybe one more in this video. Okay, Friedel-Crafts acylation. Now, we did learn Friedel-Crafts acylation as part of the aromatic electrophilic substitution. Again, R can be CH3 or CH3, CH2, etc., right? So what if we had benzene ring? Now, remember I told you Friedel-Crafts acylation without any substituents on the ring. That was the first thing we learned. So what if I had started with this instead of R as generic? So that means, what did I say? All you do is, well, the electrophile out of this is CH3CO+, right? That's the electrophile. But when it gets added to the ring and the product is formed, the plus charge is no longer there. And all I told you is, you can basically put it anywhere on the ring. But I think for the video that I created, I put it here, right? So what if I had started with CH3, CH2, CO, Cl, and AlCl3? I think I demonstrated that also in my video. This will also is Friedel-Crafts acylation. Only thing is we changed the value of R, but the process still stays the same. So you add the CO, CH2, CH3, right? Again, whatever this portion, the Cl gets chopped, and this becomes your electrophile. Okay, and that's what gets added to the ring. Okay, this is what attacks the ring, right? and that's how we end up with this. Now in this case, it can go pretty much anywhere in the ring because it's an uncluttered free ring structure. Okay, we also learned about substitution effects in a separate video, so I hope you're comfortable with those because that's a concept that we will come back over and over again throughout the course. All right, so I'm going to stop here, and I got one more video on synthesis of ketones. I don't want to just clump them all in just one video, so I'll stop here and I'll finish the remaining of the synthetic procedure in the second video. All right, so stay tuned.